everyone, and welcome to my IBM Coursera Advanced Data Science Capstone project. For this project I chose semantic segmentation because it has a wide variety of implementations, especially in insurance industry, where it can be used as a risk mitigation tool, actually as a first stage of risk mitigation tool where you can predict potentially risky situations on the road and warn drivers in order to let them avoid those risky situations. For this project I've chosen a photo version of the Cambridge Driving Labeled Video Database. It consists of 701 images of different road situations, which is not so many, taken into consideration that I'm going to train quite sophisticated model. All those images are manually labeled into 32 different classes, and those classes are distributed very unevenly, with major classes having around 10 to 15% of the total space of the images, and minor classes having less than 0.5% of total space of the images. And I expect it will be a hard task for the model to correctly extract the features and classify those minor classes. My original image size is 960 to 720, and I will not resize those images because I don't want to damage the labels. To perform correct classification, I need first to convert labeled images into 1D arrays where every pixel will be converted to its value, its label value, and then to one-hot code them to get an array of size 960 to 720 to 32, which corresponds to number of classes. Architecture-wise, I needed a model that has lots of convolution layers to extract even the smallest features to correctly predict all my 32 classes. So after doing some research, I chose UNet model as my basic architectural decision, but of course I needed to adapt it to my data set, to image size, to number of classes, and so on. So in the end I came up with the adapted UNet architecture. So this is the final architecture of my model. You can see that it has almost 19 million parameters, which would present a hard task for my computer to train this model, but I'm sure it will handle this. So let's see how it works. And here is the visual presentation of the results of classification. You can see that even after 10 epochs, model was able to correctly classify the major classes that are presented most frequently in all the images. After only 30 epochs, classification quality improved a lot, and in the end, after 500 epochs, all the classes except those minor ones I've mentioned before are classified correctly, and the model stopped improving its validation loss stopped decreasing and its loss stopped decreasing as well. So that's the moment I decided to stop the training, and I'm quite satisfied with the results of it.